Hello everyone, guys, I'm Utkarsh and I welcome you all to this session on data handling with pandas. So guys, let's have a look at the agenda for this session. The agenda for this session includes combining data frames, and we'll look at the different methods of combining data frames such as merge, concat and join. We'll also look at the set and the reset index functions. Now prior to this session, we have discussed about series and data frame. We have covered a couple of data frame properties and a couple of data frame operations and functions. We have also discussed reading and writing to Excel and CSV files. So guys, let's get started with this topic. So I'm switching to the Jupyter screen. So guys, the first step to combine the data frame is to have a data frame in the first place, and for that we need to import pandas. So over here I've imported pandas. Next, to combine the different data frames, I'm using D1 in the data in the dictionary D1. Over here I've mentioned a couple of customer IDs. Okay, let me write it like this. I'm calling the customer IDs as C_ID. And then we have 10, 20, 30, 40, 50 and 60, and these are the different products. So these are the customer IDs, they are buying these products, right? So the products are A, C, A, B, D, D, and over here I'm creating a data frame with this D1 dictionary. Then I'm having another data frame D2, and as far as this D2 data frame is concerned, let's say even over here the customer ID, I'm calling it as C_ID. So what are the different IDs that I have? The different IDs that I have are 20, 40, 60, 70 and 80. These are the different customer IDs, and for these customer IDs, let's say these customers belong to these states. Let's consider the state name as S1, S1, S2, S3 and S4. And then I'm creating a data frame with this dictionary D2. Alright, and over here if you observe, we have created a data frame DF1 and then we have created a data frame DF2. And once they have been created, so let's observe them first. So this is DF1 where I have customer ID and product, and then I'm having DF2. I'll be printing DF2 as well. So guys, if you observe these two data frames, let's contemplate on the common customer IDs that we have between these two. So what are the common customer IDs? Let's write them down. So the common ones are, over here we have 10, 20, 30, 40, 50 and 60. And if you observe over here, the common customer IDs are 20, which is present over here. Then we have 40 is also here, and next we have 60. So these are the customer IDs that are common in both these data frames, right? So we have 20, 40 and 60. These are the three customer IDs that we have. Now based on these customer IDs, so this is the general information that we need to have, or we do need to have some understanding about the common customer IDs, because when we'll be applying different type of merge operations, right? So this information will be crucial. So moving forward, this is data frame 1, this is data frame 2. The first function that we're using to combine the different data frames is the merge function. So what is the merge function doing? It performs, let's say it allows combining data frame, let's say data frames, just like SQL joins. So basically over here it provides us with 4 to 5 different merging operations. The first merge operation is, so it allows joining data frames with let's say based on at least one common column. So if you observe the data frames that we do have one common column, right? That is the customer ID. So based on the customer ID, we can join the product that they ordered and the state to which they belong. So it allows joining data frame based on at least one common column. So we can have any common column to begin with, right? It can be any column. Next, let's say there are different types of merge operations. Let's understand what all types of merge operations do we have. We have inner, we have outer, we have left, we have right. These are the different types of merge operations, right? So let's have a look. Let's look at them one by one. So the first one is inner join. Inner join simply returns matching records from both the data frames. So it simply returns the matching records from both the data frames, right? So if you observe over here, so what are the matching records? These are the common customer IDs. So if we are applying inner join or inner merge, only the details for the customer ID 20, 40, 60 based on the data frames that we have, these are the only customer IDs that will, let's say, will be able to extract. So let's see this with the help of an example. So this is inner. So I'm calling this, let's say, df inner. So pd dot merge. All right, and in the merge, I'll be writing the two data frames are df1 and df2. And what is the common column? The common column is c underscore id. This is the common column. Even if you don't write, by default it will pick up the common column, and the method of joining is inner. So if you observe df inner, please see, we are only able to fetch the common records from both the tables only for the common rows. So the common rows or the common customer IDs were 20, 40 and 60. So we have only obtained data for customer ID 20, 40 and 60 for the product CBD, and the state is S1, S1 and S2. All right. So this is how the inner join works. Now, what if, let's say, the column names would have been different? Now, instead of the CID, what if I have customer ID like this? What if I have customer ID like this? So under this scenario, how would we proceed? Let's have a look. So now the column names are different, right? In df1 I'm having CID, but in df2 I'm having customer ID. So in this case we have to mention left on. Left on is customer ID, and then we can mention right on. So right on would be customer ID. All right, the right on would be customer ID, and then over here if I apply, so both CID and customer ID would be displayed, but the product and state are only obtained for the customer IDs 20, 40 and 60. So this way we can apply inner join. So it returns matching records from both the data frames. Next, if you observe, then we have left join. So left join returns all the rows from the left table and matching records from both the tables. So even in this example, before moving to the left join, let's understand the first table that we write in the merge function, right? That is the left table. So what is the left table that we have over here? That is df1. And what is my right table? The right table that I'm having over here is df2. So now, considering the same logic, if I use left join, then how would I proceed? Over here I'll be writing df left and pd dot merge. In pd dot merge, over here I can pass df1 and df2, the names of the two data frames. What is the common column on which we are joining it? So for the left table we have CID, and for the right one, in the right one, what is the common column? We have customer ID, right? This is customer ID. And what is the join type? See, the default join type is inner. We can mention it over here. Default join type is inner. Even if we don't mention the how, as we can see, the results do not change. So we can say how is equal to inner. We write it or we skip it, still the result is not changing because the default join type is inner. Now for the second example, we have to explicitly mention how is equal to left. So what is it going to do? In the left join, right? All the records from the left table would be displayed. All right. So okay, this is customer ID. Please check. So in the left table, what are customer IDs we had? We had 10, 20, 30, 40, 50 and 60. All right. So are we getting 10, 20, 30, 40, 50, 60? Yes. But for 10, 20, 30, 40, 50, 60, all the products are available, but there are a couple of customer, let's say, states which are not available. Why we don't have information on these states? Because not all customer IDs were present in DF2. So for customer ID 10, there was no state available. For customer ID 30 and 50, there was no states available. All right, that is why we are getting NaN. NaN over here implies not a number, means we have missing value. NaN stands for not a number. It simply indicates we have a missing value that needs to be treated. I hope this is clear to everyone. So this is how we have utilized, let's say, the left join, right? This is how we have used the left join. Now, Once we are done with the left join, maybe left merge, then we can move on to the right merge. So for the right merge, what can be done? So it returns all the rows from the right table and matching records from both the tables. So I can write df.write and pd.merge. pd.merge. Over here I can pass df1 and df2. So left on would be customer ID and right on would be customer ID. And what is the join type? How is equal to right. So I can simply display df right. So when I'm using the right join, correct? So it will display all the records from the right table. And what is the right table that we have? df2. What was the left table that we had over here? It was df1. All right. So we'll be fetching all the records from the right table. Now let me write what is my left table over here. The left table that we have over here is df1. And what is the right table? The right table that we have over here is df2. All right. The left table is df1, the right table is df2. And if we check this over here, what is my left table? The left table that I'm having over here is df1. What is the right table? The right table that we have over here is df2. All right. So this is the left table. This is the right table. Let me run this. So guys, from the right table, what all records do we have? In the right table, we have 20, 40, 60, 70 and 80. So let's check them. Are we getting 20, 40, 60, 70 and 80? Because it was present in df2, and in df2 the customer ID column was cust_id. So we are able to fetch all the records, and for these customer IDs, see, we don't have any missing values as far as the state column is concerned. Reason being, the state column was a part of df2 and not df1. Now from df1 we are able to fetch the product, but no, we don't have any product information for the customer ID 70 and 80. Reason being, the customer ID 70 and 80 were not present in df1. We can check this over here. 70, 80 were not present in df1. All right. So guys, this is how we can apply inner join, left join, right join. Next, we can move on to the outer join. So outer join returns all the records from both the tables. All right. So df outer would be pd.merge, and in pd.merge I can pass df1, df2. Then I need to mention left on is equal to customer ID, and then I can mention the right on. So right on would be customer ID. This is the left on is c_id, and right on is customer_id. And what is how? How is equal to df1, df2, left on, right on, and how would be outer. All right. So outer returns everything from both the tables. So I think, yeah, I need to get rid of this. Now, if you observe this, see, we have all the customer IDs. So 10 all the way up to 60 is present in CID because we were able to fetch it from the customer ID from the left table, and in cust_id we have 70 and 80 as well. So clearly for customer ID 10, 30 and 50, we don't have any information on state because customer ID 10, 30 and 50 are only present in df2. In df1, in df2 we have customer ID 70 and 80, and for customer ID 70 and 80 we don't have any product related information. So the data observed over here is NaN. All right, the data observed over here is NaN. So guys, this is how we can combine the data frames using the merge function. All right, so we have seen these 4 operations, means there are a couple of other merge options available as well. Now moving forward, let's proceed to the concat. So what is the role of concat function? Used to combine data frame along an axis. So we can say that let's say it can be considered as an equivalent of union operation from SQL. All right, union/union all operation from SQL. So union combines, let's say, similar tables. The union operation combines two similar tables. So suppose I'm having scores, all right, or let's say report data. This is report 1. In report 1, I'm having pd.dataframe, and in pd.dataframe, I'm passing the student ID. All right, student IDs are 112. All right, then 113, 114, 115. Okay, 4 records. Then I'm having names. All right, so guys, over here I'm creating this report. In this report 1, I'm having pd.dataframe. These are the student IDs. We have 112, 113, 114, 115, and then I'm passing the names. So over here the names would be, let's say, A, B, C, and D. These are the student names. All right, and then we have marks or scores. So the scores are maybe 87, then 84, then 91, and 72. These are the scores. This is report 1. Let me call this REP1. And if I print this, if I display this, these are the student reports. What if I have another set of student reports like this? This is my another set of student report where I'm passing report 2. In report 2, the student IDs I'm changing. Till 115 we have. Over here I'm passing 116, 117, 118, and maybe one of the student IDs I can take as common. So I'm considering 114. 114, then 116, 7, 8, and maybe 120. So what was the student name for 114? For 114 it was C. All right, and then D, E, F, G. And the scores could be maybe 67, then 75, then 80, and maybe 78, and then another score could be 81. All right, so this is report 2. Now if we were to combine these two data frames, we have report 1 and then we have report 2, right? So how do we combine these two data frames? Let's check. To combine these two data frames, now clearly we do understand that all the columns are common, so it makes more sense to combine them vertically, right? So it's kind of this concat operation would be equivalent to that of vstack or hstack that we have discussed in NumPy. So let's understand how the concat works. So over here I'm writing report 1 and report 2 concat. All right, okay, report 1, report 2. So this would be pd.concat, and in the concat, if I'm passing, I have to pass report 1 and report 2. Currently, if I do not pass any access, default access would be 0. So just observe the result. See, what is the result? After this, we have data till, see, these are the records from report 1 and these are the records from report 2. So clearly we can observe that the duplicates has been retained. So let me mention this over here. Concatenating let's say with this approach. All right, retains the duplicate. The duplicates would be retained over here in this approach, and we have seen this that the duplicates are retained. So this is one approach where the access of the concatenation is 0. Now we can observe that the index is not changing, right? Clearly the index has not changed. So overall the index, we do get to see duplicates. So we can deal with duplicates as well. We can handle the index part as well. So we'll be covering this in set and the reset index. So this is one option. The other option is report 1, report 2. All right, maybe this is B and previously it was maybe A. All right, so what can be done over here? Over here I can mention access is equal to 1. All right, so now if I run this, so guys, if you observe, these are the records from report 1, these are the records from report 2. So this is, let's say, no new rows are added, but rather new columns are added. And over here, no new columns are added, rather new rows are added. So this makes more sense as far as these two data frames are concerned. So this is referred to as the concat operation. The next operation that we have is the join. So join is primarily used to combine two data frames based on the index or on that of a key column, right? So it is essentially based on joining based on the index. So only if, let's say, the index are same, then we can combine the data frames using the join operation. But for practical purpose, merge operation is way more compatible, way more user friendly compared to the join operation. So let's observe the two tables that we have. We have df left, where I'm creating a data frame. I'm having id and names. All right, over here I'm having id and names. This is my data frame, and then I'm using the function set index to set the id as the index. We'll be discussing the set index in the upcoming topic. And in place true means make changes to the original data frame. So this is df left and id is set as index. Next, I'm using the another data frame which is right. So in the right data frame, again I'm having id and score, but this is right, and I'm using the set index to set the id as the index. In place true means the changes would be replicated in the original data frame. So this is my df right. Now, how to combine these two, let's say, data frames? So these two data frames can be combined using the IDs. So let's see this. So over here I'm writing d1. Let's perform left join. All right. So what needs to be done over here? I'll be writing df left dot join df right. All right. Df left dot join df right. Now in the join function, we have mentioned let's say join on. On by default it will take id. How by default it will take left. So how is equal to, over here I can mention left. And where can I store this? Let's call this dfj and left. Data frame join using left. All right, so dfj left. So what is my left table over here? Over here the left table is df left. Let's see the result. So I get to see all the IDs 1, 2, 3 and the corresponding scores are, but we don't have score for let's say 2, 3. We don't have score for 1. So over here I'm getting NaN. Likewise, I can proceed with, let's say, maybe right join. So in the right join, df dot left join df dot right, how is equal to right. Rest everything would be same, and over here I can change this to right. I can change this to right as well. So observe this, in the right table the IDs were 2, 3, 4. So for 2, 3, 4 I'll be obtaining the scores, but there won't be any name for the ID 4 because we don't have name for ID 4. See, so for 2, 3, 4 I'm getting the names and the score, but there is no name for ID 4. Likewise, I can implement inner. So this is going to be inner join dfj inner, and this is dfj inner. So df left dot join df right, and then how is equal to left. All right, how is equal to inner. So now if I run this, see, if you observe this, I'm only fetching 2 and 3. So for ID 2 and 3 we have name and the scores as well. Likewise, I can implement the outer join. So to implement the outer join, right, so this is df outer. What changes do we need to make? The only change is how is equal to outer. So it will return everything from both the tables, all the records from both the tables. So in the name column we can see for ID 1, 2, 3 we have names, and in the score column we can see that for ID 2, 3, 4 यहाँ पे हमारे पास scores की भी values given है, but we have no score for ID 1 and we have no name for ID 4. These two values are missing, or we have null values. Reason being because left table में there was no ID 4, so there cannot be any name for ID 4, and in the right table there was no ID 1 was not present, so we cannot expect let's say the right table to have score for ID 1. All right, so this is how we can use the inner join and the outer join. Next, we can utilize, let's say, the functions set and the reset index. So let's understand this. Let me consider this data frame. I'll be considering this data frame, right? Let's consider this df1, or we have this data frame, right? Let's see. We have used this data frame. Let's utilize this. So this was our data frame, right? Now in this data frame, clearly we can see that the index is generating some issue. So first of all, means the index have duplicate values, right? So how to set the index? Over here I can mention that the index over here would be list range length of this data frame. All right, list range length of this data frame. So now if I write report 1 and report 2, so now the index is handled. Okay, I think I've set the index, right? Okay, this is, yeah. So the data frame name is rep1 rep2a. Now I've set the index list range length rep1 rep2a, and if you observe over here, rep1 rep2a, what am I getting? These are the numbers, right? These are the indexes, and we don't have any duplicates. So how to set a column as index? Let's see. The first function that we have over here is set index. Why is it used? Used to set a column as index. So what can be done over here for this data frame? For this data frame, what can I do? Dot set index, and I can maybe use the student ID as the index, right? So this is my student ID, and over here I need to write in place is equal to true. So now if I print rep1 rep2a, see, as you can see, the student ID is set as index. Now if I perform reset index, the original index would return. So I have to use reset index. So what is the purpose of reset index? Just the opposite. So over here, if I'm using the reset index, right, it resets the index, resets the index of the data frame. All right, it resets the index of the data frame. Let's see this. This is okay. Yeah. So again, we have this now student ID is no longer the index, rather this index. The original index, it has generated another index column over here, and if you can observe, this is the index, the original index, right? So this is how we can utilize set and reset index. Now reset index can also be used, let's say, typically used to convert series to a data frame. All right, this is the purpose for which we can use the reset index. So guys, that brings us to the end of this session. So we have discussed, let's say, the different methods of combining data frame, and we have also discussed how to use set and reset index. So let's switch back to the PPT. So guys, in this session, we have discussed the different approaches to combine the data frame, essentially merge, then concat, and even join. And we have seen how to utilize the set and the reset index. In the next session, we shall be discussing the different data frame operations such as filtering, sorting, group by, and even aggregations. Thank you.